Hello, class. This is Mr. DeMarco. This will be your first video lesson. It's actually a review lesson of solutions of what we started right before we had to leave school for this long period of time. Remember that when it comes to solutions, solutions is a matter of understanding what it is. So a solution is a homogeneous mixture. And when we say that it's homogeneous, remember that that means that it is in the same phase. It's uniform throughout. So once the substance goes in, it's very hard to tell where it is and how much is there without experimentation. In a solution that we make, we always have two component parts. The solvent is the substance that always does the dissolving. Remember, ing is for solvent. In most cases, it's going to be water. However, in chemistry, it could be many different things. The solvent usually dissolves another substance. That other substance is the solute. The solute always gets dissolved. So if I were to give you an example of, say, iced tea mix being created at your home because you're thirsty, you would take the iced tea powder, and that would be considered your solute. And the reason would be you're putting it into a pitcher of or a container of water, and the water is going to dissolve the iced tea mix. And when the dissolving process occurs, you're left with iced tea. Now, for our purposes in class, we talked about all different types of combinations. But then we focused on using the chemistry reference table where we looked at the solutes of either being solids or gases. Okay, remember that when we talk about table G, and this is your solutions reference table, table G gives us a temperature. It gives us how much water is in solution. And then it tells me how much is in there. Now, remember that when we're looking at this graph, we always need to understand what's the solids and what's the gases. Remember that the solids are always the substances that are going up in solubility as you go from left to right. The gases, and there's only three, HCl, NH3, and SO2 are your gases. So those would be my solutes. My solvent is the actual water on the y-axis. Now, when we're talking about solutions and solutes and solvents, we need to know how much of the solute is dissolved in the solution. When we do that, we are talking about three vocab words. Again, all of this stuff should be review. That is unsaturated, saturated, or supersaturated. That will tell us how much is present in any given solution at a specific temperature. So to understand how this works and how we relate it to table G, we have to look at each one of these three pieces. And the three pieces, again, being unsaturated, saturated, and supersaturated. When we're talking about unsaturated and saturated and supersaturated, we'll start with saturated. Remember that when a solution is said to be saturated, that means it's the maximum amount of solute that will dissolve. We in chemistry call that a perfect solution. When I take, say, 4 scoops of powder, iced tea mix, and put it into my gallon of water and mix it, there's nothing on the bottom. There's nothing floating on top. It's all in solution. That would be a perfect solution. Now, we need to understand what that is on table G. Table G, remember, is our solubility curve. And if we are saturated, that means whatever we look up is going to fall exactly on the line. On the curve means that it's saturated. Now, we need to know how much water is there because that will tell me if there's extra steps. But in this first problem, notice that when we're talking about solubility, it tells me that there's 100 grams of water. So that means I can use my periodic table as it is. Now it's telling me that there's 40 grams of NaCl at 90 degrees Celsius. So I identified how much water is there, at what temperature, and how much it should be. So now let's go take a look to see what it actually is. So remember that the question was NaCl, which is right here, at 90 degrees Celsius in 100 grams of water. So 90 degrees Celsius, NaCl in 100 grams of water is right there. And notice that the point that we got is 40 grams of NaCl at 90. Notice that my point is exactly on the curve. So if it's on the curve, it has to be saturated. Okay? So again, saturated means whatever I look up on table G is going to be exactly on the curve. If we take a look at the second set of problems, something could also be then unsaturated. When something is unsaturated, that means that there's more solvent than solute. Now, for us, to make our analogy, that would be a dilute or weak solution. So if I go back to my iced tea mix, let's say the package calls for 4 scoops in a gallon of water. And as I'm making it, I only have 2 scoops. That means when I mix it, my water is going to overpower the solute. And what I taste is not iced tea. I taste a watered down version of the iced tea. What that means is there's not enough iced tea mix dissolved in the water. So it makes sense that if something is unsaturated, that means I am weak, which means I am below the curve. Now take a look at this scenario. Now I'm going to change this to red so we make more sense out of it. Here we have still 100 grams of water. So that means I can use the reference table, table G, exactly as it is. It tells me I have 40 grams of ammonia, but this time it's at 10 degrees Celsius. So 100 grams of water, 40 grams of ammonia at 10. So let's take a look. Again, it's 100 grams of water. So I know I could use this as it is. It said, let me just go back 1 second, 10 degrees Celsius for ammonia. So 10 degrees Celsius, I'm going to slide my pointer up to ammonia. And what this is telling me is that at 10 degrees Celsius in 100 grams of water, I normally should have 70 grams that is saturated. Now, the question said you have 40 grams. And notice, if I come back to this picture at 10 degrees Celsius and place a little dot at 40, notice where it is. The 40 gram dot is below ammonia on table G, which means if it's under the curve below, then it has to be unsaturated. These concepts are things that are easy to understand as long as you know how the process works. So let's take a look and examine this last scenario. We did saturated being on the curve. We did unsaturated being below the curve. And now we have supersaturated. Supersaturated, and I'm going to change colors once again. So when we get to the graph, we'll see green. Here, I'm talking about more solute than solvent. Here, I'm talking about having way too much more than I need. So going back to the iced tea example, if it was 4 scoops in a gallon of water, but I like my iced tea super, super sweet, I'm going to add a lot of more powder or sugar to make it super strong. And we call that a concentrated solution. Now, because it is a super saturated solution, we need to go above the curve on table G. So whatever I look up, I'm going to be above. But let's check it out. So here I have 100 grams of water. That tells me again I can use my table G as it is. But this time I have 110 grams of potassium nitrate, KNO3, and it's at 58 degrees Celsius. So 100 grams of water means normal water. 110 grams KNO3 at 58 degrees Celsius. So if I go back to my table G, 100 grams of water, okay? And now I'm going to have to slide this up a little bit because my KNO3 is higher. So let me just raise this up a little bit. My KNO3, let's see here. We don't need the pointer anymore. There we go. So I'm going to raise my KNO3. It's right there. And we're supposed to be at 58 degrees. So at 58 degrees, I'm going to slide my pointer up to KNO3. And that is where my point is. Now, that would make it saturated. But notice the question said 110 grams. 110 grams is right there. Okay. Notice 100 grams is where something would be saturated, but I am higher at 110. And notice 110 is higher than 100. And that makes this a super saturated solution. When we're understanding table G again, first notice how much water is there. Then look up to see what the solute is going to be, saturated, and then compare your numbers. If I'm equal, you're saturated. If I'm above, I'm super. If I'm below the curve, I am unsaturated. So we need to practice these problems to see exactly what's going to take place. So here are our two examples. Again, we notice it's table G examples, and we see that it says 20 grams of KCl at 35 degrees Celsius and 100 grams of water. So again, what I would see is, and I'll use the green, I'm going to have 100 grams of water. That means normal, and 20 grams of it of KCl at 35. So if I go, again, it says 100 grams of water, right? It says that it's 20 grams of KCl at 35 degrees Celsius. So 35 degrees Celsius, 35 degrees Celsius, it says 20 grams. So 20 grams of KCl at 35 degrees Celsius is right here at this point. Notice that the curve for KCl at that same temperature is right here. So what does that tell us? The curve would be saturated. The point that we just made is right below that point. So I am below the curve. So that means that I am unsaturated. I'm just going to put UNS. Okay, apologize for the writing. In this next example, I'm going to switch to a red color. And here I have 100 grams of water, again, normal, 75 degrees Celsius, HCl, but I have 80 grams. So first thing is I have 100 grams of water. I then see that it says HCl at 75. HCl, 75 degrees Celsius is right here. And HCl is right there. And notice that red dot is at 50 grams. So 50 grams would normally be saturated. The question says we have 80. So I'm going to put in what the question says. And notice how easy this is. I put that point above the curve. So therefore that this item is going to be super saturated. So I'm just going to put down here super for that. So again, I want to practice some of these examples with you. I'm going to put out a worksheet. Please try to answer what those things are and get it back to me. All right. Thanks for paying attention. I hope you understand what was going on. If not, shoot me an email. Let me know. All right. Have a good day. Bye.